Welcome everyone. In this video, I will show you a universal autofocus system for CNC machines, mills, and lasers controlled by GRBL-based boards. Here you can see the entire test bench. In my case, the MKS DLC32 Max board, the 3-axis motors, the power supply, and the heart of the autofocus system based on an Arduino Nano, featuring an on-off switch to enable or bypass the autofocus function. The system runs on standard GRBL. This choice was driven by the need to keep the touchscreen display active, which wouldn't have been as straightforward with more complex firmwares like Fluid and C. Power supply and electrical wiring. The main power supply provides 24 volts to the board for the autofocus electronics. I use a step-down module that reduces the 24 volts from the power supply to 5 volts. These 5 volts are connected in parallel to power both the Arduino Nano and the actuator servo motor, ensuring a stable current for both. The movement signal is taken directly from the step and DIR pins of the Z-axis and sent to the Arduino. Using the custom sketch I've uploaded, the Arduino handles the servo movement, which, via a Bowden tube, moves the probe slide into its up/down positions. Limit switch management, homing. Let's move on to safety and homing. I use micro switches in an NC, normally closed, configuration. This is a safety-first choice. If a wire breaks, the machine stops immediately. A necessary clarification. The dedicated limit switch headers on the DLC32 are JST 2.54 mm pitch, just like standard servo connectors. If you're using servo-type cables for bench testing, I recommend swapping the ground and 5 volts wires. On the DLC32 JST headers, the positive pin is at the edge of the board, while ground is in the center. The limit switches themselves should be connected to ground, GND, and signal SIG. While I am showing only one micro switch per axis here for clarity, in the actual system, they are mounted in pairs, one at each end of the axis, connected together in series. On the Z-axis, one limit switch is fixed to the frame Z-max, while the other is integrated directly into my dynamic probe. Probe mechanics and live operation. The actuator is a mechanical core. It consists of a slide carrying the limit switch, a mount to be attached to the lower edge of the laser module, a support for a servo, typically an SG90, and a 2 mm OD Bowden tube to connect the servo and the slide. The Bowden setup makes it easy to install on any type of machine. The sliding guides are made of 4 mm brass tubes with a 3 mm core inserted into the slide to act as linear bushings. The rails they slide on are 3 mm brass rods fixed to support. The touch on the material is transmitted to the micro switch via a 3 mm rod probe, held in the downward position by a small spring, similar to those found in ballpoint pens. During the demonstration, you will notice that when I press the home button on the DLC32 display, the servo moves the probe downwards. When the micro switch touches the surface, the Arduino intercepts the signal. After the second precision touch, GRBL's pull-off kicks in. The Z-axis lifts by a few millimeters. The servo retracts the probe, and the machine now knows the exact height of the material. Once the Z-homing is complete, the X and Y motors start without the tip dragging on material until they hit their respective limit switches. Focal length and compensation. Before the demo, here is a practical example of how the focusing works. I assumed a focal length of 20 millimeters and a probe protrusion in the fully down position of 12 millimeters from the bottom of the laser module. This matches the example I wrote on the plywood board, which happens to be my machine's exact setup. The difference between the focal length and the probe protrusion gives us the value to insert with $27. the GRBL homing pull-off. In the example, 8 millimeters. Convertibility from laser to spindle. One of the strongest points is versatility. Thanks to the autofocus on-off switch, the system is easily convertible between a mill and a laser engraver/cutter. To use the spindle, simply flip the switch to autofocus off without changing any wiring or hardware. In this case, you just need to invert the Z-axis direction in GRBL using the $3 command. This allows for homing upward Z-max. To clear the work area instead of moving towards a material. Total flexibility for 3-axis machine owners. Conclusio. And all the STL files, G-code for the 3D printed parts, wiring diagrams, Arduino Sketch, and assembly instructions are available via the link in the description. They are designed to be fully replicable. The STL files include 3 different versions for 3 switch sizes and a container for the MKS DLC32 Max board. Thanks to the SD card on the DLC32, you can run your jobs offline, knowing the focus point will always be perfect. If you need to cut thick material, say 8 millimeters plywood, the laser focus should be set to the center of the thickness. Following our previous example, that would be 20 millimeters minus 4 millimeters, half the thickness, resulting in 16 millimeters from the material surface. With light burn, you can simply add a macro at the start of your G-code. G91, set to relative coordinates. G0Z4, lower the Z-axis by half the material thickness, example. G90, return to absolute coordinates, then begin the job. Thanks for watching.